All right. Hello, everyone. I'd like to welcome you to today's SAT prep session, where we'll be discussing the math without calculator portion of the SAT exam. In this session, we'll be explaining what to expect on the math without calculator section and how to approach it so that you can get a better score on the exam. My name is George, and I am one of the University of Chicago interns at the Education USA Mexico City Center. And I would be joined today by my fellow intern Danielle, but unfortunately she's not present. She will not be present for today, but that's okay. I will be leading today's meeting. So yeah. Um, Before we get started, I just had a bit of an icebreaker here briefly, and it's basically I'm basically just wanting to ask, like, how are you guys feeling about the SAT without calculator portion? It's all right if you want to unmute and speak or write in the chat how you're feeling about the SAT math portion without calculator specifically, but yeah. Well, hello, Taib. I recognize you. Welcome. All right. If no one wants to answer, that's fine. We can get on. We can continue with the information here. So let's go ahead and go here. So for this, I'm going to briefly explain what's on the SAT without calculator test here. So the SAT math test in general is designed to test students on the areas of math most important in college and career success, because in colleges they generally will expect like a baseline level of math, and that's what the SAT math test is supposed to like test on, those kinds of material, that kind of level of math. Um, well, the SAT math test is split into two separate sections, one without calculator, which is what we're going over today, and one with calculator, which we went over in last week's session. And it's okay if you weren't there, because the recordings will be available online, and we'll also have another session on it in a few weeks as well, like once again. But anyways, as I mentioned, the SAT without calculator test is the shorter portion of the math test, having only 20 questions on overall, 15 of which will be multiple choice, while 5 will be grid-in questions. And I'll get into what grid-in questions are. The questions fall into four main categories, or three main categories, actually. It should say three, but I forgot to update it. But these categories are the heart of algebra, the passport to advanced math, and additional topics in math. And I'll be going into more detail on these specific categories in the subsequent slides. And for this portion of the math test, you have 25 minutes to answer all the questions. Whereas on the math with calculator exam, you'll have, I believe, 55 minutes to answer more questions than 20. But for this SAT math without calculator portion, you have 20 questions and 25 minutes to answer them. Now, what should you expect in this exam? Well, you may not use a calculator at any point in this exam other than the math with calculator section, which means that during this math without calculator, obviously you cannot use your calculator at all. Otherwise, you may be dismissed from the exam testing center and your scores will be canceled, meaning they will not grade your scores and your test will basically be void, meaning nothing that you've completed for the exam will be like valid for any sort of credit or anything to send to colleges or anything like that. So for the duration of the math without calculator portion, you should keep your calculator under where you're sitting, under your chair where you are sitting on the exam site, and only use the calculator when you reach the math with calculator section of the exam, of the SAT exam, which is the last section, I believe. Yes. Another thing you should expect with the math test, which includes both the math without calculator and math with calculator section, is that a formula sheet will be provided to you during the math test. But these formulas will generally cover primarily geometry, which will help in answering some questions in case you don't remember the formulas for certain things like area of shapes or volume of certain shapes. So yeah, this is what the formula sheet will look like. As you can see, includes like references to like formulas for the area and circumference of a circle, area of rectangles, various triangles, and as well as the volume for various shapes such as the rectangular prism, the cylinder, the sphere, and cones. And it also has some extra information down here about the number of degrees that are in a circle and radians. Radians is another degree of measure which is most commonly used in the study of trigonometry. But yeah, this is the formula sheet you will be receiving during the exam for the math test on both portions. And you can use these whenever these sorts of questions come up. So yeah, moving on here. I'd also like to explain briefly what the grid in questions were. As I mentioned previously, for your 20 questions, 5 of them will not be multiple choice, but rather they will be questions that you fill in, that you bubble in your answer. So like instead of picking one of 4 choices, you have to actually write your answer here. So we can see in the first examples here, let's say your final answer for whatever question is 7/12 as a fraction. You can express this by bubbling in 7 here. The 7, because what you see here is there's bubbles for the numbers as well as the different operators, such as a decimal point, a fraction, a division symbol. So yeah, for 7/12, you would bubble in 7 on the first line, the divisor sign here, which is the forward slash. Then you'd bubble in 1 and 2 for 7/12. You'll also have to actually write the actual answer here. So it's not just a matter of bubbling in the numbers, you have to actually write them out in the boxes above as well. Now, if you want to write an answer with a decimal point, like 2.5, you would do that here. 2, you would bubble in 2, then you would bubble in a decimal point, and then you would bubble in a 5. Now, for certain answers, there's actually more than one way you can bubble them in. For example, the fraction here, 2/3, is a non-terminating fraction, meaning that in decimal representation, the writing goes on infinitely. It's a series of 6s that go on infinitely. Obviously, you can't express that readily. So for the SAT, you have multiple ways of writing it. You can either grid it in as a fraction, as you can see in the first option, where you grid in 2 and the divisor sign and a 3, or you can bubble in an approximation of the decimal value of 2/3. So we know it's 0.6666 repeating infinitely, but for the answer, you can bubble in a decimal point and 666 if you want, or you can also round it here. So you can see this is the same answer, except you write 0.667, which is just the same decimal value, but the same decimal approximation of 2/3, but it has a rounded value at the end. And another thing to note about bubbling in these answers is that if your answer does not necessarily have to take up all 4 of the squares. If you're, for example, these other cases that shows down here with bubbling in the answer 201, you can bubble it either starting from the right, you can bubble it either starting from the leftmost column here as shown on the right answer bubble set, or you can write it like towards the right side. Either position works as long as you have the answer actually bubbled in. And if you're not using any column, then you should be leaving it blank. You don't have to bubble in anything for it, and you don't have to write like a 0 or anything like that. You can just leave it blank, as you can see here, as well as in the previous examples, such as the 2/3. notice that this column is left blank, and in 2.5, this column is also left blank. You can bubble in an answer that doesn't take up all 4 of the columns in either way, and it will be correct. Like it'll be like accepted as a valid answer. They'll be the same. So yeah. Are there any questions about this, by the way? And another thing to note real quick is that if you guys have any questions throughout the presentation, feel free to like unmute yourself and speak and ask your question, or you can also type it in the chat if there are any questions about what I'm showing on the screen or anything I'm talking about. Yeah. So are there any questions about this grid and question form answering format? Also, this number here should say 5 because there's 5 grading questions on this portion. Okay, if there aren't any questions, then I'll go ahead and continue. I'd also like to talk briefly about some additional resources for studying. These are for the most part free, but I'm going to explain them. I'm going to explain them a bit more in detail. Khan Academy is probably going to be like it's probably the best resource you can use for reviewing and practicing for the SAT. It's not just the math portion, but also all of the SAT in general, because they have videos and exercises for all the sections of the SAT, the reading and writing, the math with and without calculator, and it's completely free. So you can go on Khan Academy and look under their SAT resources, and you can you can watch videos explaining the concepts and do practice problems. I see Samuel, you have your hand raised. You can speak. Are you all right there, Samuel? Oh, you muted. Okay. Yeah. Samuel, if you're unable to speak, you can ask your question in the chat. But in the meantime, I'm going to continue for now. Oh. Do you have a question, Samuel? All right, I'm just going to continue. But like again, if you want to ask your question, you can go ahead and speak or write it in the chat if you're unable to speak. But yeah. So as I said, Khan Academy is a very good resource for practicing for the SAT, including math, especially with the math portion, as you'll have various problems you can do. The other significant and also completely free resource here is the College Board website, because the College Board website offers several different practice exams for free that you can download and that you can take on your own. Like you can what you can do is you can like get the practice exam, set up a timer for yourself and try and go through the entire exam, or you can go through a single portion of the exam, like the math with calculator, and you can consult the answers that they have online as well for them. So that's also a good way to practice for the format of the SAT, and managing the time you have for solving the problems and answering. So that's also a very good resource to have. And these two are the ones I primarily used in my studies. Samuel, we are discussing the SAT exam, specifically the math without calculator portion. There are four portions to the SAT. There's the reading exam, there's the writing exam, and there's also 2 sections for math, which is math without calculator and math with calculator. Today's session is on the math without calculator session. Yeah, so that's what this topic is, in case that wasn't clear. Yeah, these next 3 resources, they offer some free resources, but it's generally more paid. Like they offer other resources that are paid, and while you may not necessarily need to like pay for these resources if you don't need to, but these are also additional resources to keep in mind if you want to look for more like free material, because they have some free material on offer. Oh, okay, I can slow down. Sorry about that. Yeah, so in this slide, I'm just going over some resources to help practice for the SAT exam. The first two in particular are some of the best ones that are also completely free. Khan Academy lets you practice for the SAT without by doing practice problems and watching and like getting to watch videos explaining concepts that will be tested on the SAT, or that could be tested on the SAT. While the College Board offers practice exams for the SAT so that you can try and take the SAT according to the timing of the exam. Like you can time yourself for a specific amount of time, however long the SAT is supposed to be overall, and you can try and test yourself that way and see how well you do under the constraints of the SAT exam for how much time you have per section. Are there any other questions on these resources?
Hello, can
Yes,
you hear me?
Yes, hold on one second.
Okay. What is College Board? What is the meaning of College Board?
College Board is a nonprofit organization that, among other things, is the main organization that administers the SAT exam. They're the ones that create and like give out the exam for people to take. I listed them here as a resource because they also offer additional practice SAT exams for you to try and take at home. So you can like take the exam at home and see, and like take one of their exams at home and see how you do, like according to the time limits that you have per section, because the SAT is a timed exam. So yeah, that's what the College Board is.
Okay.
All right. Are there any other questions about the resources on here? All right. If not, then I will go ahead and continue here. So these are
Yes, let's continue.
Yes, I'm continuing. These are the different areas of math that will be tested on SAT. I forgot to omit this one right here, the problem solving and data analysis. This is not real. This is not an area of math that is tested on the SAT without calculator portion. Rather, it is something that you'll encounter on the portion of the SAT math with calculator. So you don't have to worry about this, but I will go ahead and explain briefly the other areas of math that you will be tested on in the SAT. And after this, we will go over each area of math and work out some practice problems of these different areas of math to see the kind of material that you may encounter on the SAT. So the first one here is the first area of math we have here is the heart of algebra. And this primarily focuses on linear equations, which can also include systems of linear equations and functions. And they may ask you to create equations that represent a situation, like in a word problem. It may ask you to solve an equation or a system of equations and make connections between different representations of linear relationships. If that seems like a lot, it's okay. We'll be going over these different fields and what the different things they talk about in more detail. The Passport to Advanced Math section here focuses on the kind of math that you will need in order to pursue further study in some disciplines such as science or economics or career opportunities in STEM, which includes science, technology, engineering, and math. So the Passport to Advanced Math area requires familiarity with more complex equations or functions, which will help prepare you for dealing with calculus and advanced courses in statistics, some of which you may encounter in college, depending on what you're studying. But chances are you'll probably end up having to learn about calculus. So the purpose of the advanced Passport to Advanced Math section is to test you on the higher level concepts that you will need in order to like understand calculus or other higher level math that you will likely learn about in college or in the professional world. The last area of math here is just additional topics in math, and these may include topics such as geometry, trigonometry, radian measure, and complex numbers. This is like the kind of subjects that are not necessarily covered in these other two. So they can be of various types. We'll go over a little bit of that too. Are there any questions on these areas of math besides like questions on individual ones of them? Because we're going to be going over those in detail in the subsequent slides. Are there any questions? All right, if not, then I'll go ahead and continue. So the first area of math that we're going to be focusing on here is the heart of algebra. This will be working with, as I mentioned earlier, these are the sorts of questions that will ask you to work with linear equations, expressions, inequalities, and generally one or two variables, as well as graphs of linear equations. Now, for these next few slides, I ask that you grab a paper and pencil, as we'll be doing some math to show you the kinds of things you may have to do on the SAT. So if you could go ahead and grab a paper and pencil or some sort, and I'll get back to you in a bit as we will do some problems and I'll explain them for those that may not get it. All right, I will now go ahead and continue. So this first problem we have here is an example of a linear equation. It basically represents a simple equation involving usually one variable that you have to solve for. And yeah, so this question here, it's asking, given this linear equation, x minus 1 all divided by 3 equals k, and k equals 3, what is the value of x? Like, you have the problem here is asking you to solve for x. So what I'm going to do is I'm going to give you guys a little bit of time to try and solve this problem and leave your answers and try and leave your answers in the chat or talk or say your answer. And then afterwards, I will go over the problem for anyone that may not get it. All right, we already got one answer from Taib and another one. All right, I'll let you guys work this out, the rest of you. All right, so it's seeming like people are getting the priority answering. I'm going to give just a little bit more time in case anyone wants to write in their answer as well. right. Okay, so the correct answer is D, as most of you have already gotten. I'd also like to, I'm gonna ask if there's any specific confusion on the problem at all before I go ahead and explain it, or is there like, is it fine? Are they connected still? All right, I'll go ahead and prepare what I need to explain this on the computer. So just one moment, please. Let me just prepare this real quick. Okay, let me continue and briefly explain this problem because it's kind of simple. So we have the original problem here. X minus 1 divided by 3 equals k. Normally this would not be exactly solvable, but we are provided a value for k. We know that k equals 3. So what you must do is you must substitute this value of k in place of it. So we know k is 3, so you write k here. You write 3 here, and from here you can proceed to solve for x. The way you would do it here is by first multiplying both sides by 3, as this will get rid of the division over 3 on the left side. And what you'll be left with is x minus 1 equals 9. And from here, you can solve for x by just adding 1 to both sides. And this in turn gets rid of the minus 1 term. And what you're left with is x equals 9 plus 1, which is 10. Therefore, the answer is D. All right. Are there any questions about this? Also, I wanted to explain briefly, Emmanuel and Julieta, we are currently doing some practice problems that are of the kind that you may encounter on the SAT math portion of the exam, specifically the one without calculator. That is, as that's the focus of this session here. Yeah. So are there any questions about this problem? Samuel, you can speak and ask your question. Oh, yeah, of course, Julieta. Yeah. Yeah, this session will also be recorded, so you can also like catch up on missing details at another time. So yeah. Samuel, do you have a question to ask about this?
No, I don't have a question.
Okay. Right, I think we'll move on. Unless Samuel wants to ask the question in the chat, then you can go right ahead. But for now, I will continue with the presentation here. So the next type of problem I'm going to show here for the wait. Oh, okay. I'll see you then, Hector. Thank you for coming. All right. So for the next kind of problem that I'm going to show here, which is specifically under the heart of algebra, the heart of algebra is the field of one of the fields of math that may be tested on the SAT without calculator portion, which focuses on linear equations like the one that we just solved together. So yeah, this is one example of a problem that may appear. And now for the next kind that I'm going to show here. This one is an inequality. The question here is asking, which of the following numbers is not a solution of the inequality 3x minus 5 is greater than 4x minus 3? Oh, Samuel. Oh, you're asking about the previous question here. How do you get to 9? How do you get 9? Okay, before we get to inequality, I'll go ahead and show this again. So the way it started here is the problem started with x minus 1 over divided by 3 equals k. We don't know the value. We didn't know the value of k to start, but the question here explained that k equals 3. Now that we know that k equals 3, what we can do is substitute 3 in place of k. So we can put that 3 in here, which is what we end up with in this next equation here, which is x minus 1 divided by 3 equals 3. You can disregard this portion right now because that's before we continue to solve the equation. But once you substitute 3 in place of k, what you get is an equation with one variable x, and the question is asking you to solve for the value of x, like what is x supposed to be, so that this equation is correct. And you're asking about how to get to 9. Well, when you're given this little equation here, x minus 1 divided by 3 equals 3, what you do here is get rid of this divided by 3 portion of the left side by multiplying each side by 3. And by doing that, what happens is this 3 and the division by 3 get canceled out, because multiplication is the opposite operation of division. So these two basically cancel each other out. And what happens on the right side is that no such cancellation or anything happens. So what you end up with is 3, which was originally k, multiplied by 3. And that's what gets you 9 on the left side. So the equation then ends up becoming x minus 1 equals 9. And from here, to solve for x, you simply get rid of this minus 1 by adding 1 to both sides. And what happens is what you end up with here is 1 minus 1. And because of that, it equals 0. So it effectively also cancels out on the left side. So what you end up getting is x equals 9 plus 1, which is 10. And that's the final answer for this equation. I hope that helped clear it up some more, Samuel. Any further question on this, or is it all okay? All right, let's continue then. So as I was saying previously, this next question focuses on inequalities, which is something that may also be tested on the SAT math portion or math test. So this question is asking, which of the following numbers out of the number choices here is not a solution of the inequality 3x minus 5 is greater than 4x minus 3? So I'll let you guys go ahead and try and work that out, and then we'll come back together and I'll explain the problem for anyone that may need help. All right, I'm going to give it a little bit more time and then I'll explain.
You must say, yeah, man, I could give them.
Okay.
I'm back with them here on Bana, your school now. Mamma Kana. Nkamankana go that time. Whether I'm ever never.
Okay. So let's continue then. For this question, the correct answer is A, which I saw some people already got. But yeah, I will now proceed to explain this problem in more detail. So yeah, let me just open this up real quick. Okay, so we are starting with the original equation that we were or inequality that we were given here, namely 3x minus 5 is greater than or equal to 4x minus 3. And the question here is asking which of the following numbers is not a solution of the inequality. To figure this out, we have to solve for x in this inequality. And here we can do pretty much the same operations that we would do as if this were an equal sign, as if the question was 3x minus 5 is equal to 4x minus 3. You can solve the inequality in almost the exact same way, which is what I'm going to show here. So what we want to do is we want to get x onto one side. And to do that, we can subtract either 3x from both sides or 4x from both sides. But for the sake of convenience, I'm going to just subtract 3x from minus 3x from both sides. So what ends up happening to the equation is we are left with -5 is greater than or equal to x minus 3. And from here, we have a single x with one as a coefficient, an invisible one as a coefficient, so we can get we can solve for x now. And to do this, we simply add 3 to both sides so that this minus 3 disappears from the side of x. So we do it on both sides, and -5. Oh. Type. Oh. Yeah, just 1 second here. Yeah. So as I was saying, we'll have when you add +3 to -5 here, you get -2, and we keep the sign greater than or equal to x. So the solution of the problem becomes -2 is greater than or equal to x, but we can flip this around and we can also write it like this: x is less than or equal to -2. This happens because we're flipping both sides, but we must also flip the direction of the inequality symbol to follow it. So what we have is the solution is here is x is less than or equal to -2. So yeah, let's look at the answer choices we were given and see what's correct here, what's supposed to be the answer here. So let's take the answer -2 here. If we say that x is -2, what we end up is -2 is less than or equal to -2, and that's correct. That is a solution of this inequality, but that's not what the question is asking for. It's asking for a number that's not a solution, with one in that if you substituted x here for that number, it would be incorrect. So as you can, because of that, the answers -3 and -5 are also incorrect because they're all less than or equal to -2. However, when we look at the answer -1, when we look at this writing -1 is less than or equal to -2, that's incorrect because -1 is actually greater than -2. So therefore, it's not a solution of the inequality, and it's therefore the answer that they're looking for, that's being asked for here. Because another thing to keep in mind with these sorts of with SAT questions is they may ask for what is not something. It may, instead of asking for like what's the solution to this problem, it may ask what's not a solution or what's not something. So it's important to pay attention to the wording of a question. Otherwise, you may end up picking what may seem like a correct answer, but is not actually what they are looking for in the question. Are there any questions about this inequality problem or inequalities in general? If there are no questions, then I will go ahead and continue. This next one here, this next problem we have is a system of equation. It basically is, we are given, for this problem, we are given we're given two equations consisting of two variables, and the question is asking you to solve for both of these variables. So the question is asking what is x and y in this system of equations above, and I'll let you guys go ahead and give it a shot on this problem. All right. I think I'm going to give it a little bit more time, although we saw someone has already answered. But yeah, I'll give it just a little bit more time for anyone else who wants to try and answer. All right, I think I'll go on with the explanation then. The correct answer to this question is actually B, which is x being 3 and y -8. And I'll go over that now. Just one moment. Okay, so let me just clear this real quick. Okay, so we started with the two equations here. We had 3x plus 4y equals negative 23. Yeah, and then the next one we had was 2y minus x equals negative 19. Now, there are different ways you can solve a systems of equation problem, but the one that I feel would be the easiest to do here is what I'm going to show you here, because what we have is a single x here. We have a single x. We don't have an equation where like every variable has a coefficient different from 1. So what this means is that we can solve for x here in the second equation in terms of y. So let's see what that would look like. So to start, we want to isolate the x, which we can either do by subtracting 2y or adding x to either side. Both works, but for now I'm just going to show 2y because that's what I ended up doing for this. So what we're left with is negative x equals negative 19 minus 2y. You can't simplify that further because we don't know what y is yet, but that's okay. This will come in handy in solving the whole equation next. And then what we can do is just multiply both sides by negative 1 to get rid of that minus sign. And it's basically just flipping the signs on both sides. So what we end up with is x equals 19 plus 2y. Now that we solved x from the second equation in terms of y, what we can do is we can plug this value into the first equation here in place of x in the 3x. So let's see what that would look like here. So what we get by doing that is 3 times 19 plus 2y plus 4y equals negative 23. It may not look all that pretty, but as we simplify this, it'll work itself out and look nicer. So that's okay. So 3 times 19, that's 57. And it may be something that you may have to work out like by writing down like 19 times 3 and solving it by hand, but that's okay. Sometimes you may encounter situations where you may have to like hand multiply like that in the SAT without calculator portion, but that's okay. As long as you're able to multiply, it should be fine. And then, so as you can see, we multiply the 19 by 3, and then we must do the same to this 2y here. So we get 3 times 2y, and that equals 6y, because 3 times 2 is 6. So we have 6y, and then we have the rest of the equation that we already knew, plus 4y equals negative 23. When you combine these two together, you end up with a nicer looking equation, 57 plus 10y equals negative 23. Oops. Negative 23. And now what we must do is isolate the 10y term so that we can eventually divide. So what we do here is just subtract by 57 on both sides. And then what we are left with is 10y equals negative 23 minus 57 is negative 80, because it's essentially just an addition problem, but negative here. So we have 10y equals negative 80. Then what you do to solve for y is just divide both sides by 10. And you end up with y equals negative 8. And now that we know the value of y, we can use it to solve for x again, because we already have an equation for x in terms of y. So we can just go ahead and plug this value back into the x equation we had. So we had 19 plus 2 times negative 8 And 2 times 8 is 16. So we end up with an equation that looks like 19 minus 16, or I should say plus minus 16, which is essentially the same thing. It's saying you're adding 19 and negative 16 together. So it ultimately is like a subtraction, 19 minus 16. And for what we get from there is 3. So therefore, x is equal to 3 and y is negative 8. And that therefore becomes the solution of the whole of the systems of equations. Because when you plug in 3 in both either equation and negative 8 in all the equations, you'll get the correct result. You can also use that as a way of checking your answers. You can plug in your x value into the first equation, the y value into the first equation, and work it out and see if it equals negative 23. And likewise, you can do the same thing for the second, and then you do the same thing for the second equation and see if it's correct. Something I would not recommend doing for this kind of systems of equation problem, however, especially if it's multiple choice, is trying to take whatever answer is here and plug it into these equations, like trying to put negative 5 for x and negative 2 for y and seeing if it's the correct answer. The reason for this is because you may run into problems where doing this kind of guessing and checking will end up taking more time to like figure out which one is the correct one than if you just solved it normally like this. Because what may happen is you may end up checking all the answers and then the last one may be the correct one. And because of that, you will have wasted time substituting the answers of all the other incorrect problems into the equation and then realizing the last one is actually the correct one. So it's better to know how to solve these sort of problems rather than try and like substitute, like just guess and check. And well, yeah. So are there any questions on this problem or how I solved it? All right. All right, let's continue. Let's continue then. This last one here is it's easier, but it focuses on absolute value because that's another field that may be tested during this linear equations. So this question is asking, for what value of n is n minus 1 plus 1 equal to 0? So you can go ahead and work that out real quick because this is a simpler problem, so it won't take as long to answer and explain. So let's go ahead. Okay, I think that'll do for this equation, for this problem here. The correct answer is D. There is no value of n such that this equation here, this expression here, absolute value of negative n minus 1 plus 1 would be equal to 0. So let me go ahead and explain that real quick. So let me just erase this real quick. Okay, so we want to write the expression down, which is the absolute value of n minus 1 plus 1. And what this question is asking is, when is it equal to 0? So we can set this up as an equation and see what happens. Now, there's an easy way to actually to determine the answer for this problem in particular that may come in handy. what you can do is you can isolate the absolute value, and this is something you should probably do for most absolute value equations anyway. But what you want to do is you want to isolate the absolute value. The same way you would if, like, let's say this about absolute value of like x, then you would want to isolate it so that you can start getting the two different solutions that may or may not exist for this. Well, let me show you what I mean. So to start, what you would do here is subtract both sides by -1, and so that the absolute value portion is isolated and alone on one side of the equation. And what we end up with is this here. And when I was talking about an easy way to determine the correct answer for this, this is the way, because what you will notice here is that this equation is asking for when an absolute value function is -1. But the thing is, absolute value functions are never negative, because what happens is, let's say you have an absolute value of 2, then it just equals 2. But if you have the absolute value of -2, it's also 2, because that's what the absolute value function does. If you have a negative number inside an absolute value, it will evaluate positive, and if it's positive, then it will stay positive. But because of that, it's impossible for any absolute value function, no matter what's on the inside, to end up negative. So like someone answered 0. So let's look at what happened if you substitute 0 in. So you have absolute value 0 minus 1 equals -1, and the inside of the absolute value would turn out to be -1, the absolute value like this. But the problem is, as I mentioned before, if there's a negative value inside an absolute value function, it'll end up being positive. So the way you evaluate this absolute value function is making whatever's inside positive. So that ends up as 1. And this final result that you would get by substituting in 0 is therefore incorrect. So the correct answer for this equation is D, because it is impossible for this absolute value function to be a negative number. Now, before we can move on to the next question, I also want to briefly explain what to do in case of absolute value functions that aren't negative. Like, let's say you had to solve some different equation. Let's say it's asking for, let me just erase this. Let's say it was asking n minus 1 equals 2. Now, the way you would solve this is you would have to branch this equation into two different ways. And let me show you what I mean. So on the first side, you're going to solve this equation as if the inside were just positive and normal. So like you have n minus 1 equals 2. And that's because the inside of this absolute value function is positive. And then on the other side, you have to solve the equation as if the inside of the absolute value function was negative. So you would get up with, you would basically take the inside of this and negate it. And then you would have to solve the equation that way. So you would get negative n plus 1 equals 2. And from here, you would have to solve for both of these equations to get both possible answers of n. Or sometimes you may end up just getting the same answer for both, but in this case, they will be different. So solving this side, we add 1 to both sides, and we get n equals 3. So that means 3 is a possible value of this absolute value function. So we get, if you put 3 in here, you get 3 minus 1 is 2. The absolute value of 2 is thus 2. In this case, it's a little different. So we subtract 1 on both sides, so we end up with negative n equals 1. And then to solve for n, we just multiply both sides by -1, which is just flipping the signs. So we end up with n equals -1. And that's another possible solution of n that can go inside this equation, because -1 minus 1 is -2. But since the -2 is inside of an absolute value function, it becomes positive, so it equals 2 as well. So that's that's normally how you would work with absolute value functions. It's just that in the problem I showed here, it was a bit special because you basically the problem like had a shortcut in showing that like, okay, it's possible to solve this problem without like having to do this branch off sort of thing, by remembering the fact that absolute value functions can never be negative. Are there any questions about the things I talked about? All right, if there are no questions, then I will go ahead and continue here. And from here, we'll be going to the next area of math that will be shown on that you may see on the SAT. And this portion is the Passport to Advanced Math. And as I explained earlier, the questions that fall under this category deal with more difficult math questions. This is the kind of material that you may be taught in Algebra 2. And these may include topics such as quadratic equations, nonlinear graphs, exponents, radicals, and other functions. Okay, now the problems here may be pretty tricky, but that's okay, because I'll go over the problems, and you'll also be able to learn more about the kinds of problems that are in this section through resources like Khan Academy, because they have videos and practice problems for you to learn about what I'm going to show you, about problems I may show you here. So the first kind of problem you may end up seeing on the SAT is a simplification problem. So this problem is just asking you to simplify the expression here, which includes various terms of variables with X and Y. So it's asking you to simplify it, like combine. It's just simplifying the equation so that it doesn't look like this. So go ahead and give this a try. All right. Yes, I'll go ahead and continue with this. The correct answer here is C, and I'll go ahead and explain it now. Yeah. So let me just erase this real quick. Okay. So the original expression we were given was x squared times y minus 3y squared plus 5xy squared minus negative x squared y plus 3xy squared minus 3y squared. So the first thing you're going to want to do for this kind of problem is evaluate any signs like this. This negation sign here means that everything inside these parentheses will be will have their signs flipped around. So you can think of it as doing just a -1 multiplication on each one of these terms. So what you're going to want to do is rewrite at least that portion of it. So I'm just going to rewrite the whole equation for the sake of consistency. So x squared times y minus 3y squared plus 5x times y squared. And so the way we simplify this to start, this negative times this negative term becomes a positive. So you can think of it as plus x squared y. Oh wait, let's close this off actually. Yeah, plus x squared y, since we multiplied this. Next, we multiply this negative sign by this term, 3xy squared. Since it's positive, it ends up becoming negative. So in our simplification, we write a subtraction. So minus 3xy squared. And then we do it once more for this last bit here, negative 3y squared. Since it's negation, we turn this term positive since it was already negative. And that's what we do here, plus 3y squared. Now, the way you simplify this, an expression like this, is to keep an eye out for like terms. Like terms mean like these are like the x and y values, they have to match up. Like you see that, like let me show you an example. So we see this x squared y, right? Well, it could have any number, any coefficient next to like 3, 7, -5, it doesn't matter. But what you have to look for are terms that end this way in x squared y times y. And when we look throughout the equation, we see one other instance of it. So we see these two terms, and what you can do is you can combine them. Since we have a positive x squared y here and another positive x squared y that's being added, this simplifies down to 2x squared y. And then let's look at the next term we have here, -3y squared. So to find like terms for this one, you have to look for any one of these values here that ends in a y squared. And we do find one here, which is plus 3y squared. And what happens here is that we have these two, and when we add them together, what happens is they actually cancel each other out, because we have 3y squared minus 3y squared, -3y squared plus 3y squared. That ends up evaluating to 0. So they basically cancel each other out and don't contribute anything to the simplified equation. So you can like cross them out. If you see terms that are the same, except they're different by the sign, that means you can cancel. That usually means you can cancel them out like this. Now the last term we have here is an xy squared. So we're going to look for other terms that have xy squared. And there's only one other one left, which is the -3xy squared. So when you combine these two, what you end up with is 5xy squared minus 3xy squared. It's basically just like 5 minus 3. And that's just 2. So, and it's positive, so you do an addition. So you get 2xy squared. And this is the final simplified equation of all this. 2x squared times y plus 2x times y squared. Are there any questions about this and simplifying expressions like this? If there are no questions, then I'll go ahead and continue with the research with the next problem. You guys are doing great. You guys are doing pretty great, by the way, on solving these. Good job. So yes, let's continue here. This next one is a bit more complicated, but it's basic, but it's actually not as complicated as it looks. It's just manipulating the equations here. So this problem gives you an equation for m in terms of P. So it says the formula above gives the monthly payment needed to pay off a loan of P dollars at R% annual interest over N months. Which of the following gives P in terms of M, R, and N? I'll go and let you guys give this a try. Right. I think I'm gonna go ahead and start explaining this. So the correct answer is B, as some of you have already gotten. So let me explain this because this problem is actually not as complicated as it looks if you know what if you understand what the problem is asking. So let me go ahead and write this long equation out real quick. So we have m equals this very long and windy expression, but I'm gonna show that it's not as complicated as it looks for those that may be confused about this problem. Okay, so we're given this very not very nice looking equation here for this problem. And what it's asking for is it's asking for what an equation for P in terms of M, R, and N. But here's the thing. The beautiful thing about what we've been given with this problem is that P is entirely isolated. It's not a part of any one of these complex fractions or anything like that. So the way we can think about this is as if this were just one giant fraction multiplied by P. And therefore, and from this, it becomes much easier to actually solve since we see that it's just a fraction here and P isolated. So what we can do is we can isolate P by dividing this fraction on both sides, and that will give us the answer. But for the sake of being more clear, I'm just going to do it like in 2 steps rather than one. So as you can, to start off, we can see that at the bottom here of this fraction, we have this term here. So what we can do is multiply both sides by that whatever's on the bottom. So we have 1 plus r over 1200 over n minus 1. And by multiplying both sides by this, so I could say, let me just copy this. So if we multiply, both sides by this, what ends up happening is that on the right side, this multiplication and this division cancel out. So then you're left with just the top half of the fraction times P. And on the left side, you have M times whatever was on the bottom. And then from here, let me just copy this for the sake of ease. So we are therefore left with this. So we have on one side P times whatever was on the top half of the equation and M times what was on the bottom half. And from here, we can just divide both sides by the top half. And well, we get this. So what ends up happening is, since we divide both sides by this, what happens on the right side is that they cancel each other out because it's just one. Since anything divided by the same thing becomes one. Like 2 divided by 2 is 1, 3 by 3 is divided by 3 divided by 3 is 1. Same principle applies here. Since you're dividing something by itself, it becomes 1. So it effectively ceases to exist. And because of that, we can erase basically the whole thing. And what we are left with is P equals the whole expression that we started with, but flipped upside down almost, and then multiplied the whole thing by M. And that's the answer that B showed. That's the answer that's shown here by B. P equals it's the bottom half here of the original equation, but on the top, and then the top half of the original equation on the bottom half, and all of that multiplied by M. Because remember, P at the start was isolated. Everything, all the complex math and all the complex fractions and everything was on one side, and from there it's just multiplied by P. P is not part of anywhere in the original complex fraction, so there's no need to worry about like trying to get that P out of the fraction. So it's just a matter of moving the fraction to the opposite side, the way I was showing it earlier with the multiplication and the division like this. And that's how you get the final answer here. You don't even have to try and multiply out that n exponent or do any like simplification. You can just work with these terms as is. So it's important to keep an eye out for things like this that may seem complicated, but are actually just pretty simple if you know what you're looking at. So are there any questions for this problem? If not, then I'll go ahead and continue with this. The next equation here deals with exponential functions. So this problem is asking if 3x minus y equals 12, what is the value of 8 to the x divided by 2 to the y? This might be a little tricky, but if that's okay if you can't get it, I'll explain how you would go about this, but go ahead and give this a try for a little bit. I'm going to give this a little bit more time, and then I'll go over it. All right. Yeah, I'll go ahead and explain this because it might be a little tricky if you don't know exactly what you're looking at here. The correct answer here is A. So let me go ahead and explain why it's A. Yeah, let me just clear this and we'll get started. So to start off, we were given this equation here as just an established fact. Don't know the exact values of it, but we know this to be true, which is 3x minus y equals 12. Now that we have this as an established fact, it'll be something that comes in handy a little later. But first, let's look at what it's asking for. It's asking for the value of 8 to the x divided by 2 to the y. Now, at first glance, it may seem like you can't really simplify. It may seem like you can't really simplify this, but one way to think about solving exponential equations like this is to think about numbers in terms of one common base. Now, one thing to keep in mind in this problem is that 2 to the third power is equal to 8. And that is, in fact, that's something you can substitute in this part of the equation here. And what we end up getting here is 2 to the third raised to the power of x. Let me just write that, x over 2 to the y. Now, this can be simplified by just combining the two exponents together, because if you have any value a multiplied to a power of b and all of that multiplied to the power of c, then this is basically just equivalent to a to the power of b times c, all in one exponent. So that's what you can do here. So we end up simplifying this to 2 to the 3 to the power of 3x over 2 to the y. Now, this can also be now that we have a common base to work with here, you can also simplify this using rules of exponents. Let me show you what I mean. The rule in play here that we're going to want to put in place to simplify this is this rule. Given an exponent with a base of a, let's say it's raised to the power of b. If it's divided by another exponent a to the power of c, which can be a different value, like this, then this is equivalent to a to the power of b minus c, all in the same exponent like that. And with this property in mind, we can simplify this equation here, because these two bases, because both the top and bottom half of the fraction have the same base, which means we can apply this rule. So this ends up becoming 2 to the power of 3x minus y. And from here, we can now look at the fact we established earlier, that 3x minus y is 12, and substitute that into this. We don't need to know the answer. We don't need to know what x or y is. We just know that 3x minus y is 12, and we're seeing that in this exponent here. So we don't have to care about what x or y is. We just know that this together is 12. And from there, you can just substitute 12 in place of that expression. So what we end up with here is 2 to the power of 12. And that's the final answer. Are there any questions about this? All right, if there aren't any other questions, then I'll go ahead and continue. So, yeah. So this next one here is going to be it's going to be a bit trickier than the others, but it's okay. So this is asking if x is greater than 3, which of the following is equivalent to this rational function 1 over x plus 2 plus 1 over x plus 3. So this is this is basically testing the manipulation of polynomials or rational equations In this case, it's a rational equation. So go ahead and give this a try. All right, I think I'm gonna go ahead and explain this now. But the correct answer to this equation is, to this problem is B. So let me go ahead and explain. Let me go ahead and explain it here. Just go ahead and erase this real quick. So given the, so we said if X is greater than 3, then what is the value of this complex rational equation? Now, to start off, though, in order to simplify this, we first have to look at the bottom half, which is what we're going to do here. So we're going to look at this, and we're going to just look at it like this: 1 over x plus 2 plus 1 over x plus 3. So what we have here is an addition of two rational functions that don't have the same denominator. And the way to solve this, or to simplify it, is to rewrite both of these rational functions so that they have common denominators. And an easy way to do that is to look at these denominators here in both of them. And what you want to do is you want to, for the common denominator that these two functions will have, it'll be this here multiplied by this. So let's look how the first one would be written. So since the denominator is x plus 2 times x plus 3, what happens since we now have an x plus 3 at the bottom, in the denominator of the first term, we must also have it on the top. The reason for this is because we're not trying to change the value of what this rational function is. We are just rewriting it in a way that will allow us to combine these two terms, even though they don't have the same denominator. So what happens is we multiply this left one by x plus 3 on both the top and bottom. And the reason for this is because what will happen is this effectively can cancel out the top and bottom half, and it'll end up being the same as this again. We're only writing it like this so that we can add the two rational functions or fractions together. So we're going to do the same thing on this right one. So we once again have the denominator x plus 2 times x plus 3. Since this x plus 2 was not on the bottom half before, we also have to write it on the top half. So we have x plus 2, and the reasoning is the same. These x plus 2 on both sides will cancel out, cancel out technically. So it's the same value as what this was. It's the same thing. It's just rewriting it in a way that allows us to add it. And now that we've done this, what's happened is we can now add the top halves of these rational functions together because they have the same denominator. We can do that now. It's basically the same thing as like trying to add like 1 plus 5 plus 1 over 4. We basically just find a common denominator to add them by. So like we could do like 4 over 5 times 4 plus 5 over 5 times 4. And that's what happens. We end up with 9 over 5 times 4, which is just 9 over 20. That's basically the same principle that we are doing here, because as you can see in this first one, the terms cancel, so that they become 1 over 5 again. And likewise, 5 over 5 cancels on the right side, so it becomes 1/4 again. But we're just writing it like this so that we can add them together. And from here, when you add them together, we end up with the top half being 2x plus 5 over this whole thing again. So now that we have this, we can multiply out the bottom denominator, because we can't simplify it any further. We can't like do any cancellation on the top to try and simplify it. We just have to multiply it out. So what we get is 2x plus 5 divided by, so we got to do a binomial multiplication here. So we have, to start, we have x times x, so we have x squared here, and then we do x plus x times 3 plus 3x, and then we do the inside here. This is called the FOIL method, which you may have learned in school, but it's like first outer terms, inner terms, and then the last of both. So next, after we did the x times 3, we do 2 times x. That's another term in the final in the result here. And then the last term is just 2 times 3, and which is 6. So this is the final result of what's at the bottom of this equation here. The thing is, we simplified all this, but it's on top, but it's underneath a 1 over. So we have here 1 over 2x plus 5 over x squared plus 5x plus 6. Because it's underneath, it's in the denominator of this fraction. What this means is, to simplify it, we just flip this around and get rid of the 1. So what happens is we just simplify this by writing this bottom half on the top like this, x squared plus 5x plus 6 over 2x plus 5. This is known as a reciprocal, because what you're doing is you're just flipping the top and bottom halves of the denominator. And this is what's the actual final answer of this. Another thing to know is that this x is greater than 3 isn't necessarily it's not particularly relevant. It's just to make sure that no negative term, it's not trying to account for negative terms or terms for when, like, if x is -2, then you would end up with a 0 in the denominator. It's just there so that you can't run into that sort of situation where a denominator will be 0. And so that's why there's that x equals 3, but it's not particularly relevant to solving the equation. But yeah, are there any questions about that? All right, if not, then I'll go ahead and continue. There's no problem associated with this, but this is just a brief rundown of quadratic equations. These are equations that generally come in the form of A, which is any coefficient, times x squared, plus B, which is any other coefficient, times x, plus C equals 0. Or it may also come in a factored form, like what I showed previously, like in the example of x plus 2 times x plus 3. it can also come in that form. It can come as x minus n times x minus m equals 0. Now, there are strategies to solve quadratic equations through factoring, like trying to factor an equation of this form, ax plus bx, ax squared plus bx plus c, trying to factor it into a form such as x minus n times x minus m, but not all quadratic equations can be factored. Now, if a quadratic equation can be factored, then that means the solutions that exist for x are just n and m. Because if x is n, this means the first expression in the parentheses here is 0, and 0 times anything is 0, so that's one solution. And if it were m, the same thing happens. The expression on the right becomes 0, and whatever this is times 0 will always be 0. So those are the two solutions to the quadratic formula or the quadratic equation. But like I mentioned, not all equations of this ax squared plus bx plus c form can be factored. But regardless, there exists a formula that can be used to solve any quadratic equation of this form, provided that a is not 0, because if a is 0, then it's no longer a quadratic equation. But the formula here is shown as negative b plus or minus the square root of b squared minus 4ac, all of that divided by 2a. The plus or minus is basically there to indicate that there are two solutions to the problem. One where you add b to the square root here, and one where you subtract it. But yeah, it's all, as you can see with the square root, it's very possible for quadratic equations to have no real solutions, but rather imaginary ones referring to like solutions that have a negative square root somewhere in them. So yeah, but this quadratic equation works even with those in getting those solutions. It will just be imaginary solutions though. That's the only thing. But anyways, let's I'm going to move on with this. It's just basic rundown of quadratic equations. They're also something that Khan Academy will cover, and you'll probably stumble upon some problems involving quadratic equations on the SAT practice exams. So yeah, there's plenty of places to practice quadratic equations. I'm going to give a brief rundown of the additional topics in math because we're kind of a bit low on time, so I don't have really any extra problems to do here. You guys did great on the problems that I have shown here today, so good job for that. But yeah, so the additional topics in math, the questions in this category usually cover math topics not presented in the Heart of Algebra or the Passport to Advanced Math, which usually include problems about geometry, trigonometry, and angles. Here I have some images for trigonometric functions, the most important ones being sine of an angle theta, the cosine of an angle theta, and the tangent of an angle theta. The sine of an angle is equivalent to the length of its opposite side, the side that's opposite of the angle, over the hypotenuse, which is the longest side of this right triangle, because these trigonometric functions only work on right triangles like this. So the hypotenuse is the longest side. The cosine of an angle theta is calculated with the length of the side that's adjacent to the angle theta over the length of the hypotenuse. And the tangent of the angle theta is just the opposite side, the length of the opposite side of theta over the length of the adjacent side of theta. It can also be thought of as the division of sine theta over cosine theta, because they will equal the same thing. The tangent of theta can be written as the sine of theta over the cosine of theta, and like I said, it'll just be the same. And this here is showing similar rules for determining triangles that are similar. Similar triangles refer to two triangles that have the same shape, but they aren't exactly the same size. Like they have the same proportions and such. And that's what I'm showing. That's what's showing here. The first test for similar triangles are two angles that are the same. So for example, if the angle CAB is equivalent to the angle GEF here, and the angle ABC, which is an angle that's right next to the one we just talked about, is the same as the corresponding angle on the other triangle, which is EFG, then that means these are similar triangles, because since we determined that two angles are the same size, that means the third one will also be the same size. The second test you can do for this is side angle side. First, you check if two angles or two corresponding angles of the triangles are the same. And then you check the proportions of the corresponding sides that are next to the angle. So AB and EG correspond to each other in these triangles. And you want to take the proportion of them with the length of AB over the length of EG. If the proportion of the other side AC over EF is the same as this proportion here, then that means these two triangles are similar. It's basically just asking for the proportion of this and this. Is it the same as the proportion of this over this? And the last test that there is just side, side, side. And the way this works is if all the proportions of the sides are the same, then they're similar triangles. Like AB and EF correspond to each other if they have the same proportion as BC over FG and AC over EG, then they are similar. Usually you'll probably be given like numerical values for some numerical values for these triangles. And you'll have to you may have to work with similar triangles or identify them and such like that. But yeah, that's all I'm showing here in the additional topics briefly. So with all those topics covered, here's some advice for the SAT with math without calculator. It's supposed to say without, I forgot to edit it. The primary piece of advice I have here is to do practice tests. As I pointed out, there are many available on College Board's website, which can be linked, there's a link to it right here if you want quick access to it. It's just bit.ly/SAT practice test. And from there, you can go and download, I believe College Board has at least 10 different practice tests for you to try. And you can time yourself on each of the corresponding portions and see how you do given the time constraints, because the SAT is a timed test after all. You should also practice math concepts on Khan Academy. And there are resources created specifically for the SAT math portion, both with and without calculator, which include the topics that I talked about today in today's session that I went over with you. There's a lot of practice problems on Khan Academy, so it's also a very good resource for you to prepare for the SAT. Now, for actually doing the test, another thing to keep in mind for not just the SAT, but for any test really, is just that if you struggle with some problem, if you're struggling, like if you don't know if you're not sure how to do it, or there's some other issue with it, you should just skip it and move on to the next problems, and then look back at it later once you have it done, because it's better to avoid this complex problem and at worst getting just that problem wrong while being able to get all the other easier problems correct than just being stuck on that one problem and also neglecting all the other easier problems. Because the more problems you do, the more chances at points for the SAT you will have. So if you're stuck on a problem, don't stick with it too long. Just move on and do other problems that will probably be easier. So that way you have more problems completed, more chances at correct answers, and more points for your exam. And this last one I have here, this is for your own sake to do it, but you should try and write out your work. And while showing your work is not required for the SAT, it will help you in evaluating the correct answer rather than trying to do it all mentally. And it also makes it easier to double check your answers for mistakes, because if there are any mistakes, if you look when you're double checking, you'll be able to follow the work that you did to solve the problem. And you may notice any inconsistencies or mistakes, like maybe you multiplied something wrong. But yeah, it's best to write out your work. To make sure that like when you're double checking, you can find anything bad that you made, any mistake you may have made. So yeah. And with that, we are now reaching the end of our session today. But before we leave, I have here a study group on WhatsApp for anyone in these sessions who wants to like ask either me or the other intern Danielle about any questions regarding the SAT or maybe specific problems on the SAT. Like maybe you're doing a practice exam and you stumble upon a problem that's confusing and you don't know how it works and why the correct answer is what it is. You can ask those sorts of questions in this WhatsApp study group. There's a link to it right here. It's just bit.ly/study4SAT. The link is case sensitive, but I'll go ahead and type it in the chat so you can click on it if you want to. If you want to join the WhatsApp group. So yeah, you can ask any kind of question about the SAT here. It doesn't have to be about the SAT math. You can ask anything about like reading or writing in this WhatsApp group. So yeah, if you want to join, I'll leave this up a little bit. I'll leave this up for a little bit so you can go ahead and note down the link or click it so you can join later. So yeah. All right, with that, I will go ahead and just quickly share next week's session. Next week, we'll be going over the reading session. We will be going over the reading section of the SAT once again. In case you're not registered for the event, the link is right here. It's happening at the same time as today at 4 p.m. Central Time. So yeah, the link is here to register in case you haven't registered already. So I'll leave this up for a little bit in case you want to note it down and register. But yeah. Every week we'll go over the different sections of the SAT. We have now covered all of the sections of the SAT in these sessions once, but we're going to do it once more for additional review and extra like information about like problems and such. And with that, I now conclude this session, and I would like to thank you all for attending, and I hope I can see you again next week at next week's SAT prep session. Thank you, everyone. You're now dismissed.